Ignition sequence starts.
Good morning and welcome to Mission Control Houston. You're getting a live look in the International Space Station Flight Control Room, where the Orbit 2 team of flight controllers has just started its shift of monitoring station systems and working with the Expedition 61 crew members. They are just finishing their lunch break and are about to go back to work. Commander Luca Parmitano and his crewmates are looking forward to a busy few days, as the station will see one cargo vehicle depart and another arrive, carrying more than 4 tons of supplies, including hardware for another set of spacewalks.
Welcome to Space to Ground. I'm Gary Jordan. This week, cargo continuously coming and going as humans continuously inhabit the station, now 19 years strong. The Japanese HTV-8 cargo vehicle is scheduled to depart the station on November 1st after its 34-day stay on the station loaded with trash, including old nickel hydrogen batteries that were swapped out earlier this year. The cargo vehicle will burn up upon re-entry into Earth's atmosphere over the Pacific Ocean. On November 2nd, Northrop Grumman's Cygnus cargo vehicle will lift off from the Wallops Flight Facility in Virginia. A new record of 8,200 pounds of cargo on Cygnus will make its way to the station on top of the new Antares 230 Plus rocket that will give that mass the extra boost. You can watch both of these events on NASA TV or the agency's website. New cargo making its way to the station means more science for the Expedition 61 crew members to get their hands on. Scientific investigations make up 2 tons of the cargo aboard Cygnus. Investigations range from radiation to space food. Specialized tools to work on the alpha magnetic spectrometer will be used on upcoming spacewalks to repair this experiment that's looking for evidence of dark matter and antimatter. A special vest called AstroRad may shield astronauts on Artemis missions and beyond from certain kinds of radiation, so station astronauts will see how it fits and feels. The zero-G oven will examine the ability to bake food in space, which may provide psychological and physiological benefits for astronauts on lunar and deep space missions. These are just a few experiments that join the thousands that have taken place aboard the International Space Station since the first crew arrived 19 years ago on November 2nd, 2000. We're counting down to 20 years of continuous human presence in 2020. And throughout the year, we'll be recognizing some of the greatest moments in space station history, releasing new and unique content, and much more. See more on how you can engage with #SpaceStation20. Sending your questions on our upcoming broadcast and here on Space to Ground using the #AskNASA. We'll see you next week.
Okay, here's a quick summary of the activities and our coverage on NASA TV and NASA.gov. It starts at 10:30 Central Time this morning with a briefing about the science experiments being flown on the Northrop Grumman Cygnus cargo ship, followed at 1:30 Central this afternoon by a pre-launch news conference. But between those two events, at noon Central Time, we'll cover the departure of the Japanese H-2 transfer vehicle. As Gary mentioned, 8:30 Houston time Saturday morning, we'll start live coverage of the Cygnus launch from the Wallops Flight Facility in Virginia, and be back this coming Monday morning at 3:10 Central for capture of Cygnus by the station's robotic arm, and then again at 5:30 Monday to see the arm attach the vehicle to the Earth-facing port of the Unity module. Flight engineers Christina Cook and Jessica Meir will be at the controls of Canadarm2 this afternoon to release HTV. Cook has more than 3 months left in a mission that will run almost 11 months in total. She earned many of the usual credentials needed to be selected as an astronaut, but they don't tell her whole story. Here's a look at Cook's favorite extreme adventures, her dabbling with lightning, and a foreign trip that changed her perspective on life.
One thing I love is outdoor activities. I love rock climbing, surfing, camping, backpacking, anything that's a challenge that puts me in kind of a circumstance that I have to think hard to get out of or just enjoy the outdoors. So those are some of my favorite things. My favorite vacation ever is camping trips with my little sister. She's about 20 years younger than me, and we like to go out on adventures in the West, everywhere from Montana to Utah, and everywhere in between, and we just have a ball. One thing people are surprised to hear about me is that I have actually ridden a motorcycle solo across the country. The trip was from North Carolina to Montana, and I camped along the way by myself, and it was a phenomenal trip. I learned a lot about self-reliance, planning, and also just enjoyed every minute of kind of seeing the country go by. When I was in college, I was majoring in physics, and I took it upon myself to build a lightning machine, which is also known as a Tesla coil. It's a device that was invented by Nikola Tesla, and it produces actual lightning strikes that are fairly long. And I remember it was a summer project for me, and I invited a bunch of my friends over in college to check it out, and they were all completely baffled at, one, how I did it, why I chose to do it. But at the same time, I think they knew that it was near and dear to my heart. I'm kind of a geek at heart. I studied abroad in Ghana, which is in West Africa, and that trip was one of the most profound experiences of my life. It taught me the perspective that not everything that I had come to know so far in life was the same the world round, and that my experiences and my way of seeing the world was just one of many ways. And I learned about an entirely different culture and came to love it.
Along with running robotic arms and walking in space, assisting with experiments in microgravity, and other duties as assigned, astronauts on the International Space Station devote some of their time to helping students studying science, technology, engineering, and math. In this demonstration video, astronaut Ricky Arnold shows us how the molecules that make up water behave up in space.
Welcome to the International Space Station. I'm NASA astronaut Ricky Arnold. Our view from the ISS of Earth is absolutely magnificent, but we quickly realized we really should call it Planet Ocean. We are mostly a water planet. Water occurs here in all three phases, solid, liquid, and gas. And the presence of water on other planets and moons within our own solar system has us wondering, is there life there too? Well, why is water so special? One reason is called surface tension. So what is surface tension? Let's have a look. Surface tension is a property of liquids in which molecules of one substance are more attracted to each other than to molecules of another substance. Water is unique in that it has a high surface tension compared to other liquids. This is due to its polar property. The positive hydrogen ends and the negative oxygen ends create a strong bond. As they say, opposites attract, so the hydrogen end of the water tends to stick to the oxygen end in a nearby water molecule. At water's surface, its molecules are only attracted to the water molecules below and to the sides of them, as there is only air above these molecules. So the surface molecules of a body of water are pulled down, creating a more stable, stronger environment. That is why certain animals, like the water strider, can actually walk on the surface of water. Here on the International Space Station, the microgravity environment makes it easy to show how well water uses surface tension to stick together. We even rely on surface tension to help us wash our hair, those of us that have a lot. Thanks for coming along today and learning a little bit about surface tension. Want to learn more about the unique properties of water and do your own experiments? Try out the activity related to this video at the STEMonstrations website. See you next time.
Because microbes live everywhere, scientists at NASA's Johnson Space Center constantly monitor the bacteria and fungi on the International Space Station. And now they're using DNA sequencing to be able to identify those microbes on orbit without having to bring samples back to Earth for testing. Well, that's important because it's needed to keep the crews and the places that they visit safe on future deep space missions. experiments being done on the International Space Station are making advances in a whole range of scientific disciplines, including medical science that could benefit the more than 5 million people affected by Parkinson's disease. Early this year, Alexander Gerst of the European Space Agency worked on an experiment with a particular protein crystal that may hold some important insights. NASA astronaut Serena Auñón-Chancellor walks us through what that was like.
Welcome to Expedition 57 on board the International Space Station. Today we're doing some really cool science. This is Alex Gerst over here with me, and we are working on Parkinson's disease. What we're looking at here is a special protein kinase, or protein crystal structure. And the reason scientists have sent it up here to the International Space Station is because these protein crystals tend to grow larger and of much better quality. Parkinson's is a disease that affects over 5 million people worldwide, and scientists are constantly searching for a cure. And what we discovered was that here in the microgravity environment, these crystals really like to grow. So if scientists can better elucidate or clarify the structure, then they're better able to develop an inhibitor drug for Parkinson's. And not only an inhibitor drug, but an inhibitor drug with very few side effects. So what Alex is doing here today is he's obviously working on the wall, is what it seems like here in microgravity, and he is. He's got a microscope above him, and he's got a plate that he filled with this special protein crystal structure just a few days ago. Gave time for those structures to crystallize, and now he's examining them under the microscope. And he's actually interacting real time with the principal investigator on the ground to look at the crystal structure, to help improve the lighting and the clarity, and then also take pictures, which will then be sent back down to the ground. So here on board Expedition 57, we're very proud to be taking part in this experiment. I think in the past few years, scientists have realized that the microgravity environment is such a unique environment to grow things like cells or protein crystals. And it provides a new way to help us look at diseases in a better way, to help us develop new medications for these diseases. And so we're happy to be taking part in this science up here.
The International Space Station's mission is to serve as a science laboratory, to support future exploration into deep space, to promote international cooperation, and to encourage commercialization of spaceflight and space research. All of those goals come together in just one program, when the station is used as a launch pad for a series of small satellites known as CubeSats.
Small satellites yield big discoveries. Presented by Science at NASA. Remember the old adage, big things come in small packages? NASA has updated it in the form of CubeSats. Imagine a real working satellite that's so small you can hold it in your hands. Just 4 inches or 10 centimeters across, these cubes can be expanded incrementally depending on their specific mission objectives. Originally developed in 1999 by Cal Poly San Luis Obispo and Stanford University for education purposes, NASA has since used them for new science missions and to test new electronics, sensors, and software that might be included on larger missions. Mike Seablum, Chief Technologist for NASA's Science Mission Directorate, says, "The ability to test new technology at a fraction of the cost of a larger satellite makes them invaluable. It really opens your eyes to many possibilities." Just as eye-opening is the way CubeSats are quickly unlocking new scientific data. For example, while conventional satellites have long observed clouds and have provided estimates of the liquid precipitation they hold, they have never observed the smaller ice particles that create enormous rain clouds. The CubeSat, known as IceCube, contained a new sub-millimeter wavelength radiometer that could make a space-based measurement of the small frozen crystals that make up ice clouds. After being deployed from the International Space Station in May 2017, IceCube created a global map of ice clouds around the planet. Someday, this technique may help improve long-range weather models and forecasts.
A long way from Earth, Marco A and B travel to Mars and are the only CubeSat so far to leave Earth's orbit.
When the InSight mission was launched in May of 2018, The Marco A and Marco B CubeSats also began their 7-month journey to Mars.
Now InSight has successfully landed on the Red Planet. One of Marco's roles was to help relay communications during InSight's landing process. Landing data was transmitted to the Mars Reconnaissance Orbiter, where its radio stored and forwarded results to Earth after a delay. Marco A and B acted as a bent pipe signal relay during this critical stage of the mission to allow communication from Mars to Earth to happen in almost real time.
According to Charles Norton, Special Advisor for Small Spacecraft Missions in NASA's Science Mission Directorate, another advantage of these compact cubes is they allow for very focused scientific inquiries to take place. The Miniature X-ray Solar Spectrometer CubeSat, or MINX for example, is a student project using a commercial laboratory detector in space. MINX measures the soft X-ray solar spectrum in the gap of energy coverage between two other missions, RESI and IRIS. This gap region in the solar spectrum is important in the excitation of the Earth's ionosphere and of particular interest for observations of solar flares and active regions. Or consider a discovery as monumental as the origin of the universe itself. One long-standing mystery for astrophysicists is where 1/3 of the baryonic or ordinary matter that existed during the early formation of the universe might be found today. Scientists suspect it lies in the very hot halos of gas that surround galaxies. HaloSat is a CubeSat that will examine X-rays from oxygen atoms surrounding our Milky Way to determine how much missing matter may lie in the halo of our galaxy. While small in size, CubeSats have potential to make big scientific and technological impacts on Earth, in our solar system, and deep into the universe. For more about other science missions, both big and small, visit science.nasa.gov.
The range of science research being done on the International Space Station is remarkable, and yet the station program's science office hopes you can help expand it. If you've got a hypothesis to test that requires eliminating gravity as a variable, have we got a research platform for you?
Hi, I'm NASA astronaut Megan MacArthur. Did you know there's a research laboratory in space? It's the International Space Station, and it's a scientific stepping stone that's enabling us to explore farther into space while improving life on Earth. The space station provides a unique environment of microgravity, extreme conditions, and an observation platform that enables researchers from all over the world to test theories and technologies off the Earth in an extreme environment unlike any other. We welcome you to join us on station. You don't have to be a rocket scientist or part of NASA to gain access to this unique laboratory. Don't know much about spaceflight? That's okay. We're here to help people just like you every day. You might be curious about funding, capabilities, access, or maybe you just don't know where to start. Give us a call or email. We'll ask you some basic questions about your objectives, which will help us point you to the right people who could make your experiment or testing your technology possible in space. Visit nasa.gov/station opportunities for more detailed ideas, answers, and contact information, or find us at the Station Research Client Helpline. So welcome to the International Space Station. You'll soon be part of a worldwide group of researchers making discoveries on this amazing orbiting vehicle, all for the benefit of our planet and future exploration beyond.
NASA's Artemis program will return Americans to the moon by 2024 and help get us ready to go on to Mars. Knowledge of the geology of both of those locations will be important. Earlier this year, the next to last man on the moon, Apollo astronaut Harrison Schmitt and astronaut candidate Jessica Watkins, met up at the Johnson Space Center's Moon Rock Lab, so the two geologists could discuss how what we learned from Apollo will inform our efforts in Artemis.
Sample of both sides, but I wouldn't bet on it. Okay, I just got a check of that side.
They have what I consider one of the most
Can you talk about kind of what went into your sampling strategy and how you chose which samples to bring back?
The idea was to get as broad a spectrum of new samples as we possibly could, and that turned out pretty well. We did. And in fact, we sampled at least ejecta, melt, what we call melt ejecta from 3 major basins, maybe 4. We sampled fragments that almost certainly came from the deep mantle of the moon. We didn't know that at the time. That's only recently that we figured that out. And that we also then added to our broad knowledge and history of these volcanic eruptions that have occurred on the moon over time. Now, when you go to the moon on the way to Mars, Jessica, that education I think you're going to get on the moon will be very relevant to Mars. But Mars, of course, does not have that micrometeorite impact environment that we have on the moon, because it has a small atmosphere, about 1/100th of that of the Earth, and that filters out the small impact. The main weathering process on the moon are these micrometeorite impacts and solar wind spallation of the surface. Solar wind's made up of high energy particles, so they actually erode the surfaces of rocks as well as change the character of the debris layer on the moon. On Mars, the dominant erosive force is wind.
Yep.
And so if you're used to studying geomorphology here on Earth that involves wind,
you're in good shape. Yeah.
you can learn a lot about what you're going to see on Mars. But all of that comes from studying the moon.
Right.
If we hadn't had the moon, we wouldn't understand this early history of the Earth, or even speculate about what it might be, speculate intelligently anyway, about what it might be.
The NASA-led effort to return astronauts to the moon in a sustainable fashion is moving ahead all across the country. Here's an update on the progress of work being done on the Space Launch System rocket, the Orion spacecraft, and the Exploration Ground Systems hardware that will support those missions coming up in just a few years. If you'd like to get another look at any of the stories we showed you today, check us out on YouTube and Facebook. There are the addresses. And when you go there, be sure to look around, because you will find lots of cool stuff about NASA and America's human spaceflight program. If you're going to be out on the internet anyway, check out Houston We Have a Podcast. We talk to folks about their work in all aspects of space exploration. New episodes post every Friday, and today Gary Jordan gets into the details of how the Artemis missions to the moon will be done and how they'll be different from Apollo missions. He talks with Exploration Mission Planning Office Chief Najood Moranci. Go to nasa.gov/podcasts for today's episode. It's where you'll also find all of our previous episodes and the full library of all the NASA podcasts, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.